some details about the anatomy of the module, where the way that we implement is take an input and output specification and carefully design it in a way that is the developers can work on top of it, provide certain metadata, and this implementation can have different flavors. So a Postgre can have various cloud flavors, Kubernetes flavors, some third-party managed provider flavors, and things like that. And add supporting functions like observability as an orthogonal function to it. So for every module, ensure that these are the observability intent that has to be always be present in the implementation itself. So which means that these are always going to be captured irrespective of the implementations. And these observability artifacts could like be alerts, dashboards, metric collections, and things like that. So for example, let's say for a Postgre, you want to monitor connection errors and things like that. So specify them as intents, and the implementation can be different. You can specify, for example, a service level objective as an intent, but how is it really fulfilled or measured and monitored? That could be the implementation details, depending on what stack is being used, whether it's Prometheus, Grafana, whether it is Neuralink. So whenever you're interoperating between observability stack or interoperating between cloud environments, you know what are you missing out, at least. If not, like the implementation is not cloud agnostic, but at the same case, you would know that the intents are what are the implementations that are missing for this portability. So you have a central way of maintaining all of this. So yeah, so that's the final slide, which is basically how does this metadata help in the long run? It basically brings in a complete clarity on architecture. Today, all the architecture diagrams are on a documentation, or you do documentation of your architecture that gets outdated pretty fast. So nobody knows that what is written on the automation code, is it even correspondingly matching with the architecture definitions that we have created in a documentation. But by forcing people to create an architecture which is going to be, that is only one way that the manifestation happens if you put things onto architecture. By doing that, you're essentially forcing the developers to put all their intent in a systematic, structured language instead of Jira tickets. And that becomes the source of truth for your delivery. And then you can extract that information from Jira tickets to your architecture definitions and other things. And that would lead to true automations, which by true automations, I mean is that now you know for that what implementation block or what for exact configurations, if there is an IAM role that has been created or a security group that has been created or observability artifact dashboard has been manifested, what is the corresponding intent in the blueprint or corresponding intent in the declarative way that you've given it, the assets that the developers have created, exactly what it corresponds to, which means that these implementations are part replaceable, they're configurable and things like that. And that would eventually drive standardizations, guardrails, and best practices. So to summarize, essentially, this is a declarative way is to give a developer a framework or a tool where they can continue to evolve their architecture in certain ways, in the level that they understand it. Separate out implementations from intent so that your implementations are portable, and ship everything. Don't configure anything. I mean, you can obviously configure something to test something out, but then make those configurations as part of those implementations of those intents so that things are shipped and not configured to drive consistency and maintainability of your automations. So yeah, I think that was the final slide that I spoke about. I just quickly went over the last few slides so that somebody has missed out. But yeah, open for chat, folks. Yeah.
Yeah, Anshul, you had posted a comment on Discord. Perhaps you want to discuss that here.
Yeah, somebody asked a question that is it a good idea to give ability to write this manifest for production environments, right? So the thing is, the idea behind all of this is that the environment itself is another implementation detail, because when a developer wants a database and a couple of services to do certain higher level stuff, he's not thinking about environment. In fact, maybe he's just thinking about the first environment. So if you design it right, environment doesn't matter, right? And as long as you have right pipelines in place, like your changes should be tested first in a lower environment and then it should go to production and stuff. uh, the idea is that the intent definition should be singular.
Yeah, essentially designing things in layers at which people can contribute to, and then the developers will understand environments much better than it will understand infrastructure and other things. So the manifest language that we spoke about is actually a good, to a good extent, agnostic of the environment, whether it is prod or dev and things like that, because we want all of them to be consistent. Now, obviously, there are certain things that you want to specifically do in production, which means that you want to have different sizes of your pod environments, or you want to apply certain different types of um, um, access controls and things like that, which are in some way are orthogonal from the architecture that you want to deploy onto the cloud, or even your observability configurations. Uh, it has to work exactly how in the lower environment for it to be confidently say that it will work in production. So having that consistency matters fair bit, and hence the manifest can be completely or to a large extent agnostic of the environments itself. Nishant, you want to add anything?
Yeah, I just wanted to add a couple of points in terms of maybe not specific to this, but here's how I've always thought and would love to hear everybody's opinion on it. I think when we're designing systems, right, anybody, whether it is developers, architects, or anyone, I call them as systems as imagined, because we're imagining them systems. We're sort of putting them on a whiteboard, sketching them out, and sort of we are imagining the world on production to look like it. And when it's actually deployed, here's a funny, I'm sure all of us have gone through it, but when it's deployed and there's an incident, more often than not, we hear people go and say, oh, I'm surprised it even worked this way. And there's an element of what you find on production. So I call those essentially as systems as found, because you're almost discovering them again. And they have deviated from what you imagined them to be when you actually started working with them. And surprisingly, most often than not, this drift that happens between an imagination and the reality is actually what is more surprising in a lot of areas. I always think that infrastructure as code probably was a great first step to sort of reduce the drift from imagination and reality. And I think what you showed is applying those ideas at higher levels of abstraction is honestly quite fascinating, because that just reduces the delta or the drift that can be, that otherwise can manifest. Again, manifest probably overloaded here, but that can manifest because of a difference in what we thought it to be and what state we found. So I always imagine these problems to be, and I think very interesting in terms of when applying these concepts at a higher level of abstraction, how much standardization and consistency can they bring to the environments we work in. So just wanted to add that.
And Nishant, in specific to observability space that you guys work a lot, how do you think about this kind of a problem that can happen? Because the missed observability artifact is like you don't know. A lot of time what I've seen in the past is that if an alert is not coming, whether it is not coming because everything is good, or because the alert is not set, or it's not been set for a particular set of things. So that those kind of things worried me always.
Absolutely.
So yeah.
Yeah, no, absolutely. I think so. To extend from that, I think from a declarative observability perspective, it goes along similar lines. Like while a blueprint is sort of manifesting that into as a runtime on production, you also want to be able to ideally observe that data as a feedback loop on top of the same architecture diagram, right? It's almost like I imagine you are on an industrial automation floor where you have this visual map of how the systems are interconnected, and you have these blinkers of LED lights going red, orange, or green in terms of what part of the machinery is working well. This is literally like a floor plan, which is overlaid with this golden signals, so to say, and making you understand what's important, what's not, and being able to isolate those literally in real time. So being able, I mean, obviously, Pravanjan, to add, we've taken a perspective of our own in terms of how this manifests on the side of observability, because of the same challenge fundamentally, that what you imagine and what you observe, if they're not in sync, then you're building these mental models over and over again, which is the biggest time sink in terms of understanding your own systems, especially with tribal knowledge at play, multiple people joining the team, etc. And it reduces the barrier to what knowledge can be shared. It's almost a knowledge graph at play in some ways, that is encoded in the form of a declarative language that probably developers and ops and SRE everybody can collaborate on. So yeah.
Yeah, I think
said.
John also had a question about how do you approach changes in the forms that require them to like basically increase the server size of database and so on. So John, if you're here, perhaps you can also ask that question. Yeah.
Hello, hi.
Hey.
Yeah.
Hi.
Hi. So my question was around like, so everything we talked about was mostly around if it is a new project. So since I'm not thinking about it, like what environments I'm running on, so I can drive out an intent form and get an, and some other team or some other process will probably write down the infrastructure code, whatever is the guardrail for the SRE teams or the DevOps teams, right? But like, how do you face off like once they are in the production, now they want to change it? Let's say like the most common one would be like it's a pipeline should be something like this. I'm going to upgrade my servers from 2x to 4x. So action should do a couple of things. Like it should take a backup. It should have like you know the drill, right? Like whatever drill that you have. So now when you are also upgrading the servers, you whatever things that you had coupled with this architecture, right? Like observability component should already be upgraded. If alert was on, let's say 20 GB free memory, now you want it on, let's say 30 GB free memory, something like that. Makes sense? Do you face any problems with this kind of architecture in this?
Yeah, so that's a good question. So I'll actually take a couple of live examples of it. How do we look at this kind of approach? Even in fact, I'll go back a little step. In a very recent example, where the developer essentially woke up to an alert for his service, throttling and basically getting blocked on the database. And now he has to essentially, without being dependent on, and as I said, the expectation of current systems is that you respond to issues in minutes, and you can't call a ops guy and any of that. So he has to go and resize the database, and all the recipes of the resizing of the database is built in. But there is also a guardrail around it that in such certain cases of the outages and things like that, the developers, I spoke about guardrails, the manifest will contain things like this, is that this is the default size of the databases, or the developer is allowed to operate on these sort of t-shirt sizing of environments, sizes that he's free to choose if there is an outage and things like that. There is also the fact that he would be able to make that override change, and that is the only thing that will change. He'll basically go and change that. Okay, this is an outage time. I need to make certain fixes for this effective manifest of a particular environment. I want to go and resize my database. Now, the ops team, instead of writing only the implementation of this Postgre module into this, also writes the change management for it. So if this change happens, or a sizing change happens, or if the database has to be recreated, then what are the 10 steps that needs to be followed? So that is something that the ops teams writes and enables the developers, not just for that manifest, but any change in that manifest as well. So if these 5 things the developer can change, and he's within those guardrails, that he can make the database 2x large, but he can't make it 4x large. So he can do that. And if that happens, then what are the 5 things that will change? Because that is the only thing that the developer is allowed to change. Now the ops teams writes tests, makes it independently tests in the test environment, that every time the developer changes the database size, this will effectively do the right things. And then that goes shifts as the cloud runtime for the developer, so that he can operate on it. So that also makes all these changes independently testable. And you don't discover them that, okay, I go and change something and then something happens. So one of the major things that we do also is that any changes when the developer is constantly modifying these manifests for various reasons, for any outage, or he's constantly evolving his architecture, making decisions on what sizes has to be there, whatever limited things that have been given to him, those combinations are tested as independent modules, that these changes will effectively result into these 5 steps, and that will repeatedly do the same job every time it is being done. So those kind of independent testability also it enables. Anshul, you want to add anything?
No, I think you covered everything, and with the latest technologies, like we said, that we use Terraform for this, right? And you'll use Pulumi or some infrastructure as code. Chain management is pretty solved for, and for things like backups and stuff, those are the support function Pravanjan talked about in the slide, right? Like taking backups or restoring them, or most of the resizes are live nowadays. So life is getting easier to write automations also. And like Pravanjan said, even if you have to do some change management for a certain change, it is like predictable, right? So yeah.
Good. Makes sense. Thank you.
All right. I think Nishant, you had asked a question about is the manifest a standard spec that is it based on a standard spec, or is it a standard spec itself?
Yeah. So again, this is a concept. I mean, you can obviously extend it and create your own manifest. We've done a bunch of research and created some standard manifest in the absence of something like this. So we find part and parcels from different inspirations from different places, but there's no standard manifest today. So hence we created our own sort of a manifest for it, which we call as a DCI manifest today.
All right. We are just 1 minute over time, so I think we did well after coming here and
Yeah.
covering most of the topics. So we also recorded the Zoom part of it. So we'll share the slides as well as the recording, and we'll also try to share the Discord recording. We'll have to see how well it went. At least the recording went well or not. So yeah, we'll check that and get back. But feel free to ask questions here, as well as Pravanjan, you have also shared your details on the slides, so people can reach out to you. And also on Discord, also feel free to ask questions and continue the discussion. We'll share upcoming events. If you have any topics, speakers in mind around platform engineering, SRE, DevOps, software reliability, feel free to reach out to me, or post a message in Discord, and we'll try to arrange that as well. So thanks everyone. Thanks a lot for joining us, and thanks Pravanjan for sharing your thoughts on this topic. And I think it was nicely done. I think a lot of things to learn and a lot of things to think about as well. So thanks a lot.
Thanks, Prathamesh, for arranging this. Thanks, everyone.
Thanks, Pravanjan. Thanks, everyone.
Thank you. Bye-bye.